Okay.
Salam satu Malaysia and a very good revolutionary day to abide to our honorable judges, respected audiences and our fellow teams. Today, we from Sekolah Menengah Kebangsaan Sultan BADLISHAH, the name CE2 like to present on the topic how we create F1 miniature Surya racing cars. Attention, start. This is our support circuit. It shows the pit stops to be elaborated. Okay. Attention, introduction. Basically, our team advisor is Ishauddin Samsudin. We consist of 6 members, 4 Form 4 students, 2 Form 2 students. Okay, firstly, team manager, Sean Nelson, myself. Followed by manufacturing engineer, Sasi Talent. Followed by resource manager, Mughran. Muhammad Ismail Farhan, manufacturing engineer. And it's graphic designer, S. Quillen. And also lastly, graphic designer, Muhammad Ali Hafiq. Station next. This is our team formula, C times E times E times O9, which equals to CE square O9. Our team motto is creative times effective times efficient times O9. It's also our school trademark in F1 in school project. Transition menu. Transition, we head to second pit stop business plan. This is our business plan. We create our team CE square O9 and we do our work according to timeline prepared. We calculated the cost and we received more sponsors from Intel Technologies and Neverhard. Attention menu. Okay, we head to the third pit stop research. I'd like to invite Mughran to explain this research.
Thank you, Sean. A very good day. I'd like to invite everyone. Today, as the resource manager, I'd like to explain about my research during our preparation of CE209. The main concept of our preparation is about the bullet, which is popular for its speed, which combines with the F1 technology to produce a CE2 car. Technician, next. The next thing that I realized while doing the research is we are applying the physics syllabus of chapter 2 on forces and motion. The first thing that I applied was velocity. Velocity is defined as the rate of displacement. The distance traveled by our car was 20 meters and the time taken was 1.135 seconds. These are the calculation of our car. Thus, this proves that our car accelerates at 31.45 meters every second. Technician, next. The next thing was momentum. The car experienced explosion when the carbon dioxide tank is punctured out. Using the principle of conservation of momentum, which is equivalent to M1V1 plus M2U2 equals to M1V1 plus M2V2. It is equivalent to the mass of the gas and the volume of them, which is equal to the mass of the carbon dioxide and the volume of the carbon dioxide. All the cars to be raced has the same mass of CO2 tank and the same initial velocity. Theoretically, all cars will have the same velocity. What makes them different is their design and the mass of the car. Technician, next. The next thing is the drag, or commonly known as the frictional force. All the cars is affected by drag. It is our creativity to reduce drag. To reduce drag, we have to use more aerodynamic shape on the front and rear wings of the car. The car has the ability to direct air to the back and reduce turbulence. A diffuser is used to reduce the turbulence too. Technician, the pressure. Pressure is needed to maintain the car on the track. If the pressure is too high, it will slow down the velocity. If it is too low, the car may get lifted off the track. This proves that the Bernoulli's principle that we learn in physics form 4, chapter 3. The relationship is velocity is inversely proportional to the pressure. Technician, next. The next thing is how to maintain the acceleration. First, the car tire. Make sure that the car tire always touches the track while it is moving. The momentum. We should increase the weight at the front of the car to give it a bigger momentum by using the principle of an arrow which has the heavy metal head. The third thing is the downforce. We use the concept of aeroplane wing which only moves upside down. Higher pressure above the wings presses the car downwards and keeps the car on track. This is applied to the front wing and the rear wing. The last thing is the air friction. The air friction should be reduced. To do this, we have smoothened the surface of our car like our concept of an bullet surface. We smoothen using sandpaper and a few layers of liquid. Alignment of tire is accurate, bearing is tightened, and the stability is increased by lowering the point of gravity. That's all from me. I'd like to hand over to Sean.
Thank you, Mughran. Okay, we head towards the fourth pit stop, which is design. I'll hand over to Mughran on his design section.
Thank you, Sean. I
graphic designer of the team, would like to elaborate on the design we used to create our F1 project. Sketches. Firstly, a few sketches of our car was drawn, technician back. After that, the drawing was drawn to see in detail the measurement and the size of the car, technician back. After that, we also used some command solid edge principle in designing our car. For example, we used the cutout command, portrait command, mirror command, and the down command. Technician back. As we study in Form 4 syllabus ICT, system is divided into system software and application software. Thus, we use several application software in designing our car. We use the word processing, spreadsheet, presentation, graphic 2D, graphic 3D, and programming in designing our car. Technician back. That's all from me. I would like to hand over to Sean.
Okay, thank you, Vivian. Okay, we head towards the fifth topic, which is analysis. Okay, I'll testify on the analysis done. Basically, it's divided into four: visual wind tunnel, scout wind tunnel, time trial, and improvement. Technician, visual wind tunnel. This is a car simulation which is visual done for the test. Based on the reading obtained for the drag coefficient, the car V2 is lower compared to the car V1. This is for the reason why our team chose this model to be manufactured. Technician back. Scout wind tunnel technician. This is a real car test done. Based on the graph obtained from the test car wind tunnel measurement, the car V2 has less drag than the car V1. This can be caused by the more streamlined and aerodynamic body shape. The constant reading of the top of the car graph proves that it is more stable and has more downforce acting on it. Tension back. Tension thumb trial. During the thumb trial, we conducted a few some test runs. Based on the trial, we found that the car V2 has more consistent and has faster time than the car V1. This proves that there is more momentum caused by the carbon dioxide tank. Tension back. Tension improvement. We did some major improvements on the car. In the side view, the front wing has been changed to an L4 shape to produce more downforce, and also the body is lowered to increase stability. We view the top view, no hole is created on the body of the car, so the car is not flying up. In the bottom view, a smoother bottom base part is done for better efficient airflow during motion. Tension back. Tension manual. Okay, we get toward the sixth stop, which is manufacturing. I hand over to Sasi to elaborate on this innovation part.
Thank you, Sean. I would like to wish a good day to everyone out there. I, as the manufacturing engineer of this project, would like to tell frankly about the flow of manufacturing of automotive technician. Firstly, the R-type Balsa template was chosen. Then the Balsa template then was placed into the CNC micrometer machines. After that, the axle hole were drilled by our team members. Then the model was placed into the CNC to manufacture top, bottom, and the left side. Next, the process to smoothing the car was carried out by our team members. Lastly, the car was sprayed with lacquer, airbrush paint, and clear spray. Technician. Now I would like to tell about how to make a CE2 car. Step 1. We have programmed the car into the computer. Then step 2 shows the model was placed into the CNC micrometer machine. Step 3 shows the axle head was drilled. And step 4 shows the model was placed into the CNC micrometer machine to manufacture the top, bottom, and the left side of the car. Step 5 shows the car is ready, and lastly, step 6 shows the car is ready to be sprayed. Technician back. Thank you. Now I would like to hand over to Sean.
Thank you, Sultan. Alright, technician, head to the last pit stop, which is conclusion. In our key to success, we apply the knowledge of ICT and physics in order to finalize our project, which is F1 in school. Our teamwork is good and a good cooperation. Our fund received sponsor from Intel Technologies in Berhad, and we had support from our friends, family, and also teachers. Thank you for letting me hear.
Salam.
Salam satu Malaysia.